Right. Hey, folks, welcome to the May 7th, 2024 SIG Windows community meeting. This is a recorded meeting which will be uploaded to YouTube, so please adhere to the CNCF Code of Conduct, which, if you do not know, is basically translates to be nice and kind to everyone. Right, so the main topic on the agenda, which I'm going to add, is Claudio has a question about next steps with unit tests. Go ahead, Claudio.
Yeah, so we were saying that the Windows unit tests are passing currently on Windows. We are basically skipping a few of them since we basically want the dashboard to be green so we can actually move forward with having some sort of job running on every single pull request. So we make sure that we won't have any regressions. It's been quite a few of them which happened over the past few years, so maybe this is going to prevent some of them. So we decided that's probably the move forward. And we were discussing which unit tests should be included in the first batch. We were saying that we should probably run the kubelet unit tests, the kubeproxy unit tests, the volume unit tests, and maybe kubectl and a few others. Maybe not all of them, but still.
Yeah, go ahead, sorry.
Sorry, Mark. My question is, do we really need to like run only a subset of them? If they're all passing, can't we just run all of them because the unit tests, they should be cheap?
I mean, the job still runs for an hour or so. Let's see, 1 hour and a half.
Whoa,
So it's
a
not
unit test job runs
really.
for
Yes, it takes a while.
a good amount of that, at least like the first 15-20 minutes, I think is all just set up, right?
There's some setup based. We don't really need a lot of setup. Basically, we install Chocolatey and Golang and make and a few other things, and maybe build kubectl, which is needed for a few tests, testing it. But that shouldn't really take a lot of time. I'd say maybe something like 5 minutes, 10 minutes at most. But from my experience, what really takes a lot of time is actually building the unit test for the first time, basically, since it has to compile everything to say so and then run everything. So an option might be to have some sort of binary for the all the unit tests and run that. Basically similar to how you basically build an e2e.test binary for the e2e tests, but for unit tests. Maybe something that could be done. I'm not exactly sure, but I think that would reduce a lot of the time wasted in running unit tests, because again, not all of that time is spent running anything. But yeah.
Yeah, but I wonder that I feel like that should be possible. I know for like the E to E test binary gets built and then other jobs take a look and use it later. And if most of it's, populating the like just the Go module cache and building everything too, I think we could argue that just doing that extra cross build in some other job that builds the CI binaries for pull requests and sticking that in there is going to be a big improvement overall. If we want to start running the Windows unit tests later.
Yeah, for sure. And I actually forgot about the vendor folder as well. That also takes a while to pull and build basically.
Yeah. Possibly, like if we really wanted to, we could look at reusing, like having a pool of machines that this could run on. and then reuse the cache. But I think if we can build the test binaries that we need on Linux as part of an earlier job, that actually may be the way to go and store it in wherever all the CI artifacts get built and stored.
It might be weird, basically having a pool of machines to run those tests because you would still effectively have to repull all the modules, maybe, because some pull requests may actually update them. So of course you have to repull everything, or maybe some other jobs were, running on other branches. I'm not sure that's actually something that we want, but maybe. And that would require, once again, pulling all the vendor folders and dependencies. So it doesn't really help much, I think.
Okay.
So I think what I'm hearing is even if we run only a subset of tests, that's not going to really reduce the time, right?
It will
It's the
reduce
compile.
it will reduce the time, but it's still gonna run for a long time. I think
No, what I'm saying is it won't reduce it by much, is what I'm understanding. The main time goes in just compiling, unless we're able to fix the compile so that. So I think
we could maybe go down by, I'd say, half an hour or so if we limit what unit tests we're running. But I'd say we're still gonna be running for an hour-ish.
Yeah, I don't know how the community is going to react to that.
I mean, there were some complaints in the past, if I remember correctly, that I think we discussed about having the unit test jobs, and they were a bit quite displeased of the fact that we would be taking so long, especially if we are going to be blocking. That's quite a long time to run.
Yeah, so maybe Mark, maybe your idea is what we need to do is have it be built as part of some other job.
I wonder how
Then just
the regular unit tests are being run. Is it being done the same way we do, or is something already being built and basically just reuse that? Or I wonder how, because they're running a lot faster than we do, so they might be doing something better than us.
Yeah. Are we disabling like Defender and things in the jobs? That might help. And I know when I run the unit tests locally, like if it's the first time, I get a ton of pop-ups saying that all of the different test binaries are trying to access like network resources. Do you want whatever happens on Windows where it's like, do you want to give them access? So we should maybe double check with Defender.
Yeah, I don't remember disabling any defenders in the script, so that might be interesting. But
yeah, I think I can't see that reducing it drastically, like several orders of magnitude. So yeah, we'll have to look and see how the other unit tests run.
yeah, and I do have one other question. I do have another pull request in Windows testing, which enables the kuproxy unit tests. If anyone would want to LGTM that, so we can also run those as well. The failing tests have been skipped, so it should be fine for the most part to push this in, unless something else merged since I sent this one.
Yeah, and I just took a look and it's small. So
yeah, it's just basically the kuproxy tests were being skipped because they were actually crashing the entire unit test job, because some unit tests were basically doing some weird syscalls for HNS and HCS, which would basically crash the unit tests. Those will still have to be addressed. But at least we're not skipping all kuproxy unit tests.
yeah. Yep.
Yeah,
Yeah, it's been LGTM. I think that was an LGTM storm, basically. All of us on the call, most of, like, few people on the call, LGTM. So we should
and
be good there.
and I do have some other pull requests which fixes some other of the unit tests which are being skipped right now. And I think also Fabian also has a pull request for some of them. There's still a couple of them which has to be fixed and addressed. I didn't have enough time to look into them. But there was an interesting issue which I found, which is basically a bug for Windows containers. Basically, you could follow the container logs apparently in kubectl with, follow the logs themselves. But if you did that, it would actually block log rotation, which was interesting. But I did send a pull request, which basically it will make sure that it won't block log rotation if someone is following the container logs. I did send a pull request here if anyone wants to try it out and see how it goes. There's a few hacky ways, things that I did here simply because the Golang standard libraries do not allow me to set those flags, but we should probably send some pull requests to the Golang standard libraries to add some sort of option to set those flags, so we won't end up with this problem. So we could reduce this pull request to just 2 lines of code. But yeah, it was interesting to see and debug.
Mm-hmm. I'll have to take a look at that.
So, what are the action items moving forward? What should we do or look into?
I think let's take a look about disabling Defender in the job, and then let's also look to see if the other unit tests, if they cache binaries somehow, and see if we can get a little bit, see if we can get an estimate of how much time it could save if we didn't have to build all the test binaries.
Mhm.
And then I believe this work was done, there is an issue for Windows unit tests, I'm pretty sure. So probably pick that up again and open it,
And
try and get it added as an informing job, I guess.
yeah, that was what I was going to say as well. Until we reduce the execution time for the unit tests, I think we could at least have it as informing.
Mm-hmm.
So we don't. So if that happens, there's the Kubernetes team and release team, which is going to track this, and at least we are gonna know that something merged, which broke something. So at least it's still useful information, and it might still um, prevent some bugs from merging in the first place.
Yeah, and I hope that once it is an informing job, it's going to be easier to get traction on PRs to either fix the issues or fix existing issues or regressions.
Mhm. But when it comes to how many times this job will run, I don't know. Is it gonna run more than 30, 40 times per day at most? I don't think there are that many pull requests being sent every day.
Yeah, that's true.
But it's not about the number of pull requests being sent, right? It's if there are a bunch of open pull requests and somebody does retest, won't it end up getting run? It won't end up getting run if they do retest required, but if they do retest, won't it get executed?
I'm not sure how many credits there are on the testing account. I'm not familiar with any sort of limits of that sort. So I'm not sure if there are any costs concerned there.
Yeah, I'll have to look into that, especially because we're creating machines in Azure, right? Under the same account that everything else is running.
Yes, but it's only one for unit tests.
Yeah,
So
it's only one for unit tests, whereas it's multiple for
Mhm.
other tests. So yeah, I can try and take a look at that. It's gonna, I mean, it's gonna add some capacity, but not more than like than it takes for running the other Windows EDE tests on all of the PRs that we run them on. Oh, if we're capturing action items too, let's also double check and see if what I remember about the Azure CLI installation failing, causing some issues, and see if we can add a retry around that.
Do we already have some retries for other jobs? So that might be easier to add than to the
I
script.
don't know. I need to check.
Mhm.
Yeah, but we'll take a look at that.
Yeah, so the action items I had is investigate the Linux unit tests and why they run quickly, disable Windows Defender, and add retries for your CLI failures.
Mhm. Possibly add the retries. Yeah, I think that's good. Yeah.
Uh, yeah. I don't think there was anything else, right?
No, nothing else, I think.
Cool.
Was there anything else that we wanted to discuss, or should we end the meeting?
So I did ping Eric who joined. I'm not sure if Eric is still free to chat, but
Oh,
I
okay.
think Arvind, if you had a question around on GPUs, right? So I think Eric can kind of field that.
Oh, awesome. Yeah, so the question was, we had someone from Siemens come and show us a demo a couple of weeks ago where they were mentioning they were able to take a NVIDIA GPU and it needn't have been like an A10 or an expensive, grid GPU of that sort. And they were able to share it across VMs without doing any kind of pass-through. So basically a shared device. And I think both Claudio and I were wondering if that is even possible and how they were able to pull it off.
Yeah. Were these, you saying across VMs, were these like Xenon containers or just truly VMs and containers isn't even part of the question?
I think
It
it
was
was
just
a VM which also had the necessary virtualization flags turned on, so it could actually even create more VMs inside of it since they were using KubeVirt. So yeah, fully fledged VMs.
Oh, interesting. Oh, okay. Then I'm not going to be, I could speak to how we share the GPU across, process isolated, Windows containers, and how we do it for Xenon, our Hyper-V isolated containers. But if this is just across VMs, the only thing I'm aware of, I'm probably not the expert on that one. Then is there like what's the specific question? Just how can they do the sharing without doing like partitioning? Was that the
that is the
assumption?
question. Correct. Yeah.
I see. Okay, yeah, maybe we can look into that and maybe get back to you next week. Would that work?
Sure, that works, Eric. And given that you're here, we would love to hear how the vGPUs are being shared across, or how the GPU is being shared across process isolated containers.
Okay. Yeah, that one's actually fairly simple. So on Windows, there's this component in the kernel called DXG kernel. Actually, let me back up 1 second. There's kind of two aspects here. There's using DirectX, sharing the GPU for DirectX apps. And then there's the notion of sharing it for more generic things like CUDA or, whatever Vulkan or what, I can't remember what AMD's thing is called. But so I'll start with the DX one, and then I'll explain the other. In the case of process isolated, obviously we have a shared kernel. One of the kernel components is this thing called DXG kernel. So it's the DirectX graphics kernel. And it is possible for user mode processes to talk to that, whether they're running on the host or whether they're running in a process isolated container. So what happens is if you're just trying to run a DirectX app, even if it's in a process isolated container, there's one more detail I'm going to have to come back to, but let me just finish this thought. It can talk to DXG kernel, and the way the DirectX runtimes work is there's a user mode driver that needs to be loaded. So that process can come up, it talks to DXG kernel, it learns the name of that user mode driver, that gets loaded into user mode, and then it can basically compete for the GPU just like processes on the host can. Now, the one magic trick is there is a flag. There's like if you were using Docker, for example, you do Docker run -- device and a magic flag that basically enables GPU. When that flag is set, we basically expose those user mode device drivers from the host into the container's namespace. So it's possible for the driver to be loaded even inside the container. But after that, it's no real magic. It's just like another process. He got access to the right driver and he's competing for that same GPU resources. All it needs is that one flag to indicate whether it should be exposed or not. So that's with DX. Does that make sense, or any questions so far? And then I can talk about the more generic GPU case.
Yeah, I took some notes in our shared doc so that folks come back and look at it. Hopefully it makes sense. And when you talk about the driver, you're talking about the user mode driver is getting loaded inside the process isolated container.
Correct. That's right.
Okay. Yeah.
And then
what is the flag, Eric? Sorry, what is the flag that you said needs to be enabled?
It's let me look that up and add it to the chat. I don't remember it offhand. I want to get it right. Yeah. But it's just a switch that basically says, hey, this particular device should be visible to the container. So
I was concerned for a bit that there was no such switch. So basically anyone could use a GPU, even if it wasn't the intention. But you said that basically all the containers would then compete for GPU access. Is there any way to prioritize basically containers? So you want then to have some sort of QA to say so for GPU workloads. You might want to prioritize some workloads over the others and so on.
I don't believe there currently is, but I'd actually have to check with the graphics team to know for sure. But I think I'm fairly certain today, all the containers would be on an equal footing, and any processes in the host trying to use the GPU would be on an equal footing. So they'd all compete just as though all the processes were running on the host. But I'd have to confirm that as well. There might be a way to control the priority.
Yeah, because you might want to put some upper limits on how much access there's to some resource. The same reason we put limits on CPUs and memories and so on. So you won't have some sort of malicious agent, to say so, basically overexerting all the resources on a host. It would be a bit problematic,
Yeah, no, totally fair request. I just need to see what. Anyways, yeah, I don't know the answer offhand, so I'll try to get that. In the worst case, we can talk about it next week too.
Great.
I've also dropped the doc link to our doc in the chat, Eric, so you can add details there. Once you find
great.
out.
Okay, thank you.
Do you have time to talk about the general case, or is this? I know we're running a bit over time.
Sure. Yeah, the general case is not much different from the DX specific case. The same flag will enable the general case as well. The main difference is just where these drivers exist. So in the case of the general case, it's all just the main magic is making sure that these drivers are visible in the container's namespace. So, you know, I think we had the the DX specific case longer, and then the general case is a little bit newer. I don't remember exactly when that got lit up. But it's basically the same thing. It's just that in those other cases for CUDA and things like that, oftentimes there's binaries, you know, drivers essentially, again, user mode drivers, just placed in the Windows System 32 directory. And there's a certain naming convention for how they're supposed to be named so that they can be discovered and used and everything. And the same thing happens. Those basically get made visible inside the Windows System 32 directory of the container so that those, you know, non-DX GPU use cases can work as well. But there's no real difference to what the user does. As long as they have a version of the OS that supports the generic case as well, it just works with the same flag.
Sorry, I was just making notes, Eric. So this is great information. Is there any like user-facing docs around this, or is it fully undocumented?
Yeah, no, there should be some docs on the web for that. So I can try to dig that up too and stick it in your doc.
Awesome, awesome. This is great information, Eric, because we know that this is a question that keeps popping up every now and then. I don't think any one of us have the knowledge to answer them when it gets asked in the community. So this is really helpful.
Okay, yeah, great. Thank you.
All right, folks, this was a meeting that had no agenda, but now has so much agenda that we went over time. Thank you for joining, Andy and Eric. This was really helpful. We'll hope to see you again next week.
Sounds great. Thank you.
Bye,
Yeah,
folks.
thanks.
Thanks all.
Thank you. Bye.